Okay, so someone just sent me this question. It's clearly asking us to prove an identity, and I had actually not looked at the question properly, but looking at it nicely now, let's see what we can do. The first thing I'm already seeing is that we have compound angles here. It looks a lot like the compound angles of sine. So let's see how far we can get with what we know. So the first thing that comes to mind is the formula sheet. I'm actually trying to open up the formula sheet so that I can see which compound expression this is. So this is also one of those things where if you haven't done maths in a while, always be certain of what you're about to do. So this is clearly the compound angle of sine. If you have a negative here, it means that this can be rewritten as sine the 5 minus the 3x, like the 5x minus the 3x. There we go. And then at the bottom, we just have tan 2x. So I've decided to work with the left-hand side because if you're proving an identity, you can choose which side you want to work with. Usually it's easier to take something that's big and break it down. So the first thing that I'm also seeing here, or the second or third thing that I'm seeing, is that the tan 2x is clearly going to be an issue for us. So what I like to do is that since we know that tan 2x is going to be a fraction, the first thing I'm going to do is I am going to make this a fraction, and then I'm going to divide it by sine 2x over cos 2x. You see, so this division symbol, clearly, it has just replaced this line over here. You see, and then the tan 2x, we know tan is sine over cos. So since there's a 2x here, we just put 2x on both of these. So without overcomplicating anything, since this is a division symbol, the first thing you want to do is you want to change this to a multiplication symbol. Then you want to have you want to have cos 2x on top, sine 2x at the bottom. There we go. And then actually, let me make this a bit simpler because 5 minus 3 is 2 anyway. So why waste space by writing all that again? From here, this is quite straightforward now because this can cancel that. And then you have cos 2x. And then looking at what we have to end up with, well, funny enough, this whole time, genuinely speaking, I didn't even notice the minus 1. So there'll be a minus 1 here, minus 1 there, minus 1 there, and a minus 1 there. All that does not affect what we have done. So to end up with this, clearly we can just use the double angle of cos. The one that says that cos 2x is the same as 1 minus 2 sine squared x. And there's a minus 1 here. This, if you break it down, 1 minus 1 is just 0. And then you have negative 2 sine squared x. Therefore, the left-hand side is equal to the right-hand side. This was not exactly a difficult question. I'd actually not thought much about it when I got it. Don't want to sound condescending, but this is all you have to do. It's not a difficult question. If you have any questions, feel free to send them through, and then we can just work on them. Cheers.